Assalamualaikum. My name is Emilia Elyasa binti Perdaus and my metric number is 198458. And today I will give you explanations about how to use Rayleigh methods and Buckingham's methods from fluid mechanics with Dr. Manordin, and hope you guys enjoy it. Okay, now I will proceed with the problems that I choose. Okay, if we assume that the drag force acting on the body F is a function only of a free stream density, free stream velocity, body length, and the free stream dynamic viscosity. For example, D is equal to F, density infinity, velocity infinity, length and viscosity infinity. Show that the drag coefficient is simply a function of the Rayleigh method and Buckingham's pi method. Okay, now I will show to you guys the showbook on how to do it. Okay, now I will explain to you guys in Rayleigh methods. First, okay, these are the common things that we need to do, which is we need to state the variables and the dimensional quantities, which is force. They have density, they have velocity, they have viscosity, and also length, and their dimension quantities, which is for force, mass times length over p squared. We can also write in this. And for density is mass over length cube. You can also write it as this. And velocity, length over times, we can also write it as this. And viscosity, which is mass over length times and length is only length. Okay, first and foremost, you need to put an equations like this. Force is equals to constant, and we put all the variables. We exclude the force because we already put it here, so we put all the variables that we have, which is density, velocity, viscosity, and length. After that, we need to put in this bracket, we need to put an unknown to them. So we copy back the FD constants, and for density we put an A for them, and for velocity we put B, for length we put C, and for viscosity we put D. After that, we need to change all the variables here into dimensional quantities. So first we copy in here. So it will become like this. So don't forget to put the unknown here. As I said, don't forget to put an unknown here, which is for density we put an A, for velocity we put B, length we put C, and viscosity we put D. After that, we make an equation from them, which is for M. For the front M have 1, so we'll put 1 here. It's equal to. For A we have 1, so we put A here. Plus, they have D. D we have 1M, so plus D. For length, also we will do the same. There are 1 length here is equals to length. They have negative 3A here, so we put negative 3A. Then for B we have 1B plus B, and C we have 1 plus C, and for D we have negative 1, so we put negative D. And also for times, here we have negative 2, so we put negative 2 here. And for B you have negative 1, so negative B. And for D we have negative D. After that, we will have 3 equations and they have 4 unknown, which is A, B, C, and D. So we need to make it as 1 unknown only. So we put it like this. A is equal to 1 minus D as in equation 1. And for equation 2 is B 2 minus D. And for here, we can put substitute, then the answer will be C is equals to 2 minus D. Okay, after that, we put all of this, we substitute in this one, in the second equation that we do. So we put change A, B, C into 1 minus D, 2 minus D, 2 minus D. And it will become like this. Substitute the A, B, C from here. Then we put it like this. Then we separate on each 1 minus D. So density 1 and density negative D. We separated each of them. And it will become like this. Then we separate the D and the numbers such as P to the power of 1, V to the power of 2, and L to the power of 2. And all the numbers to the power of numbers, then we put it in here. We change it to the front. And also they have the unknowns, we put it at the right one. And it will become like this. So force over density, velocity square, and length square is equal to constant K, and is equal to viscosity infinity over density, velocity, and length is D. And make sure for the last one, make sure all of them are dimensionless. So we need to check it step by step. First, we put in here and here, all of them. In here, and make sure all of them are dimensionless. And make sure all of them will become 1. So like this. And we can cut it here. And L, we can cut it here after you calculate it. And T here, we can cut it here. So it will become 1. And this here also will become 1. M, T, and L always become 1, or else you need to calculate from the start. That's all for regular methods. We will proceed with Buckingham's pi methods. These are the common things that we need to do before doing the Buckingham's pi methods. Okay, first they have a step in Buckingham's pi methods. They have first step, we need to determine how this refers to the variables, the numbers of variables. So the number of variables here is they have 1, 2, 3, 4, 5. They have 5 number of variables, and the second step is n. N refers to the numbers of dimensional quantity. Okay, as you can see, 1, 2, 3, they have only 3 dimensional quantities. They are first step and second step. And the third step is you need to minus variables, minus with dimensional quantities. And you will get number of pi group. For these equations, then we get 5 minus 3, then we get 2 pi group. So we need to do 2 pi group. Next, we need to determine the repeater. The repeater is the first step. Select repeater. They have a general repeater for information. General repeater is density, velocity, length, and also viscosity density and length heat and density. These are the general repeaters, but from this question we can select the first one, which is density, velocity and length. The use of repeater will be used later on in the fifth step. Okay, fifth step, we need to do the equation for pi 1, which is we copy back these are repeaters that we already picked, so it will become like this. And don't forget to put an unknown to them. For density is x, velocity is y, and length is z. And for the first equation, they are not selected is force and also viscosity. But for the first equation, is usually we will use the force here. Then we turn all the variables into the dimensional equations. For this, it will become this will become this, and this will become this. Don't forget the force also become this. And it will become like this. Don't forget the unknown. After we change it from the variables into quantity, dimensional quantities, and we put the unknown, we make a 3 equation from them, just like m is equal to, they have x have 1m, so we put x here. So there's no unknown here, so we just plus 1 because there's 1, then is equal to 0. Then we proceed to L. They have negative 3x, 1y plus y, and plus z, and also plus 1 is equal to 0. And t is negative y because there's negative here, and negative 2 minus 2 because there's no unknown, so we just put negative 2, then it is equal to 0. And from this we can get x is equal to 1, negative 1. Then y is equal to negative 2. And from here we can know the z is equal to negative 2. We just substitute it here and here, then we can get the z. We can do the equation for pi 1, which is fd, we just took it here, fd minus, because x is minus 1, x is minus 1, so there's definitely here, and v is y, so minus 2, so v will be to the power of 2. And y, also sorry of my mistake, so y is 2, so we can just put it to y, and z is negative 2 also, so we can also put it here, L2. There's already done our first equation of pi 1. So we need to make sure there's dimensionless, just like the dimensionless, and it will become like this if we need to check the dimensionless or not. So m, we can cut it here, L after we calculate it, and you can cut it also, and t you can also cut it, so it will become 1, so it is dimensionless, so our pi 1 is correct. So we proceed with pi 2. Pi 2, we have the same method, but we already done the force that we hadn't picked for repeater, right? So they have viscosity left, so just put it viscosity here. Then just as this, we just do it as the same. So it will become like this. From here we can get x is equal to negative 1, y is equal to negative 1, and z is also, after you substitute it, and you calculate it, and it will become also -1. Then from here we can know the pi 2, which is viscosity, and for x1 is density, so -1, so just put density, and z is length, so just put length here, and y is velocity, so you just put velocity here. And after that you can check it whether the equation is dimensions or not. If you do it like this, then you can just cut it off. Then it will become 1. So our calculation is correct. So the last one we need to check to do is pi 1 is equal to f pi 2. As you can see, there's no space that I can write here, so I just write here pi 1, which is here. You just copy it. Force per density times velocity squared times length squared is equal to f functions to the pi 2, which is this pi 2 here, and this is the final answer. This is the final answer for the Buckingham pi methods for this question, and that's all from me. Thank you.